Assetto Corsa Rally was recently released, and I got the itch to play. So, I searched on Shanyu, a second-hand platform, and bought a used steering wheel simulator setup. I purchased a full set of MOZA products, the R12 V2 wheelbase and the CRP2 pedal set. During use, I noticed that the accelerator pedal seems to have a certain issue. I prepared 3 examples here. The first is a GT3 race car, where you can see the throttle pedal assembly's pivot point is not placed very far back. The second image is a BMW street car, and its throttle pedal pivot point is also relatively forward. The third is a Porsche 992 GT3, and its throttle pedal is also positioned quite far forward. I then looked at products from several sim pedal manufacturers. First, the Simagic P1000, its rotation axis is not that far forward, but it's acceptable. Looking at MOZA's own CRP first generation, its throttle pedal axis is very forward. The SRP throttle pedal axis is also under the heel. The same goes for Simacube. The CPP Evo's throttle pedal axis is also very close to the heel. Now, let's look at the CRP2 generation. We can see one problem: its rotation axis is very far back. I also found a similar issue with the AZ racing pedals. Let's first discuss some ergonomics issues. The first is the difference between pressing the accelerator and pressing the brake. Generally, the brake is heavier, and the accelerator is lighter. This specifically refers to racing vehicles, not standard road cars. The brake pedal may require a starting force of 40 kilograms, potentially up to 120 or 150 kilograms. The accelerator, however, does not require such a large force. Around 100 newtons, or about 10 kilograms, is usually enough to press it fully. Therefore, when braking, the force comes from the thigh, and the entire leg must push forward. The strength of the ankle and calf alone is insufficient to depress such a heavy brake pedal. When pressing the accelerator, control precision is key, so the force generally comes from the calf. The foot rotates forward to press the pedal, using the heel as the pivot point. I therefore created a simple physics model for discussion. First, we assume that the position of the heel does not change during pedaling. The entire foot rotates in a pitching motion around the heel axis. We quantified a change of 30 degrees. Using the vertical y-axis as 0 degrees, we considered the pedal travel to be in the range of 15 degrees to 45 degrees. In this process, the position of the brake axis relative to the heel axis is called dx and dy. I created a table. Calculations show that as dx and dy change, under these constraints, how many millimeters of relative displacement occur between the top of the foot and the accelerator pedal. I will include a link to the table at the end of the video, which interested people can download. I took a measurement, and for the CRP2 pedal in this model, dx is approximately 76 mm, and dy is approximately 22 mm. Moving under these constraints, the pedal and the top of the foot undergo approximately 76 mm of relative motion. Please note that this model is very crude and is used for qualitative analysis, not a realistic representation. Based on the theory that moving the pedal pivot forward reduces relative friction, I modeled and 3D printed a throttle pedal assembly for testing. This pedal's design adhered to several principles. First, it is compatible with the original base mounting. Second, it significantly pushes the pivot axis forward. Third, it reuses the original damper rod. Although this model was originally designed for metal manufacturing, I optimized it into a plastic printed part. I printed a total of 3 pedal faces and 3 frames for testing. Ultimately, my printed part had a dx of 40 mm and a dy of 26 mm. Under the same motion constraints, the sliding amount between the foot and the pedal was controlled to approximately 47 mm. I emphasize again that this model is only a crude model used for qualitative analysis and does not represent the real situation. Let's look at the usage of the original throttle pedal. When you start pressing the accelerator pedal down forcefully, the pedal surface and the sole of your foot have significant friction, and the entire foot is completely lifted up by the throttle pedal assembly. When you start releasing the accelerator pedal, the heel then has considerable friction with the baseplate. This is a release motion using the heel as the pivot. Repeatedly performing this action cycle causes the foot to move further and further up. Eventually, the heel breaks through the base plate's restraint, and the entire foot ends up resting on the pedal face. This is the operating performance of the throttle pedal assembly I made myself. You can see that during rapid pressing and releasing, the relative displacement between the pedal and the foot is relatively small. The heel can be firmly anchored to the base plate and the entire foot is prevented from being dragged upwards. There are two advantages to this. The first is that my control precision increases, because I can confidently place my heel on the base plate and use only the power of my calf and ankle to press the pedal. The second advantage is during rapid throttle application and release. For instance, when driving rally cars and I need to quickly adjust the throttle to control the car's attitude, having the foot securely resting on the pedal is also an operational advantage. What is very interesting is that I went through almost all the domestic CRP2 review videos, and not a single review mentioned this problem with the CRP2 pedals. My suggestion is, if you are like me and mind the excessive sliding of the throttle pedal under your foot, then do not buy the CRP2. Finding a CRP1 or using the SRP might be a better choice. Of course, the CRP2 pedal set's brake pedal is excellent, and I don't have the clutch, so I can't comment on it. The build quality is also very good, the aluminum alloy use is generous, and the assembly quality is very high. The operation of the entire pedal assembly is also very smooth and fluid. I give high praise to the overall build quality of these pedals. If MOZA is currently designing the next generation of CRP, I have a few small design suggestions. The first is to move the throttle pivot point forward and slightly lower. For floor-mounted, organ-style pedals, this results in less friction with the foot and more flexible control. The second is to modify the anti-slip design of the throttle pedal, adding more rib-like designs to reduce the contact area between the throttle pedal and the sole of the foot would help lower friction. The third point is, since the pedals are already modular and allow user assembly, you could try allowing users to adjust the fore-aft position of the entire throttle and brake pedals. Perhaps you could try a design where the throttle and brake pedals have different pivot axes, pushing the throttle pedal axis forward slightly. Finally, this discussion is limited only to floor-mounted pedals, also known as organ-style throttle pedals. The common suspension-style throttle pedals used in passenger cars are outside the scope of this discussion. This is because the kinematic geometry of suspension-style pedals is different from the floor-mounted style, and they can use a well-designed curved surface to reduce slippage between the foot and the pedal. Furthermore, this discussion is strictly limited to the CRP2 pedal. I have not raised issues with other pedals simply because I have not used them, which does not mean other pedals are problem-free.